Thanks for having me back again. In April, we were here at the Solid State Storage Symposium. And so I'd like to really talk about kind of an update from the sort of topics I talked about in April in terms of where we see the storage industry going. So just to review what we talked about, or what I talked about 6 months ago, is that Flash, the conference, of course, was largely around Flash. And even though this is the next generation storage symposium, it sure looks like most of the next generation is Flash. That everyone we've heard from today is either delivering a Flash-based storage system or a hybrid storage system. And I think that's really in line with where I see the market going as well, is that all these next generation technologies, all the innovations really being done by Flash-based storage vendors. A lot of that is because of what I see as the dynamics of enterprise storage, and I think I talked a little bit about this in April as well, which the dynamics of enterprise storage is that there's just an enormous amount of account control. There's an enormous amount of customer ownership that's concentrated in kind of the big 6 vendors. And so there's not a lot of interest in actually innovating there, that the innovation is done in startups and emerging companies. You know, some of these companies have already hundreds of millions of dollars in year in sales, have potentially multi-billion-dollar valuations, but they're still startups in a lot of ways, in that they're relatively new, they're delivering new technologies, and also they have a relatively narrow focus in the product portfolio, which really is an interesting dynamic in our industry, because customers like to buy all of their types of storage from a single vendor. And so that's something that can make it a challenge to get started. But once you get started with a really successful product, then you can be very successful with that. So to go back to what I talked about in April, so Flash, and this is something that repeats a lot of the points that others have said so far this morning, is already cheaper than disk. It's already cheaper than disk when you consider the use cases that Flash storage is being used for. That Flash is also driving the highest performance application because it's the only solution that can be used in very high performance environments, be they database environments or virtual desktop environments. And also it's rapidly moving down market in terms of IOPS. So because price is falling, the Flash storage can be used to address market spaces that have lower performance requirements because it can still beat disk in terms of cost per gigabyte. The flip side of this is data optimization is something that we see as critical for Flash differentiation. So data optimization is compression, is deduplication, is thin provisioning. It's anything that allows you to make more efficient use of your storage. And again, another thing that you heard from everyone this morning is that they're incorporating some degree of data optimization in their product that they see that's critical. And this is something that's really accelerated in Flash, but hasn't in disk storage for exactly the same reason that I started with, that because there's so much account control in these big 6 companies, these companies that have been very loath to adopt Flash technologies, very loath to adopt data optimization technologies. They don't want to see the cost per gigabyte of what they're selling to the end user decline very rapidly. They want to have that decline at a very slow year-on-year rate, and they don't want to incorporate new technologies that would affect that, even if it gives them the opportunity to make more money across the board. So in Flash, on the other hand, as I said, because it's really startup and emerging companies that are adopting Flash, they're also, from the very beginning, adopting data optimization technologies. And so really, in the Flash space, it's pretty much necessary to have data optimization, deduplication, compression, in order to be able to continue to sell, to be able to be successful. Data optimization also reduces the cost of storage further. So one of the points that we heard from a number of people this morning is that sure, at the high performance points, the Flash storage is cheaper than disk, but even at lower performance points, they can beat the cost of disk through data optimization. And the other point that I talked about then, and I will reiterate here, is that data optimization is something that's really hard to build by yourself. That this is an area of technology that, for example, we've been working in for more than 12 years, building a new storage product involves a whole bunch of kind of disparate technology areas. Building a Flash technology product, you're working with reliability of Flash, longevity of Flash, you're working on how you're managing latency, you have to work on what your interfaces are, how they're presented, if you're building a cluster, if you're building a scale-out system. And if you're going to do data optimization as well, then you'd have to devote an entire team to just that technology too. So talking about the price at a given level of performance, this is updated from the chart that I presented in April, where I talked about how flash, again, for a given use case is already much, much cheaper than disk. And that continues to be the case. So from 2012 to what we expect 2013, a high-end SAS array with a flash cache, something that you would need to achieve, say, 100,000 IOP performance level, has gone from $240 a gigabyte to $239 a gigabyte. So not a lot of savings there. However, at the same time, a high-end flash array that can deliver that level of performance, which is already cheaper at $25 a gigabyte, has already fallen to $16 a gigabyte. And what that means is that, of course, it's opening up more use cases because maybe that's not the 100,000 IOP projects that need that are getting the flash now, but the 80,000 IOP projects or the 60,000 IOP projects. So even the highest end flash arrays today, the most expensive flash arrays you can buy, are already much, much cheaper than the disk-based storage systems you'd have to buy to achieve the same level of performance, not to mention the management overhead in trying to configure those systems properly so you could, in fact, see that level of performance, not even considering the operational costs of the power and cooling for those very large SAS arrays, which are going mostly unused, that can be replaced with a flash array. Just the overall cost to deploy a storage system that reaches a particular level of performance has fallen dramatically from spinning disk versus flash. And of course, deduplication can amplify those savings even further, that you can drop the cost of a high-end flash array to well below the level of mid-range storage and open up ever more applications for those storage systems. This is a slide I presented back in April, the drivers for flash adoption. So what we've seen initially is at the top of the pyramid, those very high performance applications. Those are applications that even a little bit more performance, a few more IOPS, directly translates into value for that customer. So I think that financial services was mentioned earlier, people who are doing high frequency trading systems who, if they can analyze data that much faster, then they feel they can get that much money, that there are a small number of customers that are always willing to pay incrementally more for an incremental amount of performance. And so this was an area where flash and even DRAM-based systems have been enormously successful. But there's not a ton of growth at that kind of tip of the pyramid. So where we've seen the most growth, and where we've seen growth even this year from April to November, is in that 100K IOPS level. So these are still very high performance applications, but these tend to be more database applications, more general purpose database applications. These tend to very frequently be virtual desktop infrastructure. So in VDI environments, putting more desktops on the same virtualization host creates more load from that virtualization host. Deploying more desktops creates more load, and those are very solidly in that 100K IOP plus market. And then, of course, as price continues to drop, and as data optimization technologies become more broadly deployed, then flash storage can address that 10K IOP market level and even below, where it can displace existing disk systems. And really, the direction I see the market going, and I don't think there's been a lot of argument with this from the other vendors so far this morning, is that disk certainly will always be around, but disk is really there for capacity storage. So these are those 3 terabyte, 4 terabyte, 5 terabyte monsters for bulk infrequently accessed storage. And over time, flash will very rapidly overtake the rest of the market as price points fall, as technologies like deduplication make different data sets even cheaper to store. So the impact of deploying deduplication in one of these storage systems means that you're able to, if you do it right, still meet the I/O requirements. So one of the big challenges, and I'll talk about this a little bit more in a couple slides, of vendors that have deployed data optimization is they've said, well, we can do this because that way we can meet the price point of existing disk-based storage systems. And it's okay if our performance isn't a lot better, because even if it's a little bit better, a customer, of course, is going to buy our product. And that's true if those are the only products in the market. The big challenge with that model is that if you have flash vendors that are delivering very high performance while still also meeting the same price point, then that's going to be a very difficult sale, because now you're just the middle of the road product and you're still not the best product. And that's also specifically a problem in markets like virtual server and VDI, where the performance constraints aren't relaxed, that there's still very high performance constraints. So you need something that's not just a little bit better than the disk-based storage solutions. You still need something that's a lot better than the disk-based storage solutions, but you still have a very aggressive pricing concerns. So if you can deploy deduplication correctly within your product, you can do that in a way where it doesn't impact the multi-100,000 IOP levels of performance that the highest end flash storage systems are able to deliver. Not only that, you're able to see enormous savings from, especially in the VM and VDI environments that we see with our partners, 25x or more savings just because of the enormous amount of redundancies. And something that's kind of surprising, perhaps at first, is that, so of course, in a VDI use case where you have full images for each desktop, you're going to see an enormous amount of savings. But we've even seen in VDI environments that are based on kind of a linked clone or linked golden image, still enormous amount of savings because of what happens to those images once they've been generated. What happens to those images as they're used over time is very heavily deduplicatable. Deduplication, if deployed correctly in a product, can scale to the entire capacity of that product. That, as mentioned before, deduplication has the capability of increasing the reliability, so increasing the number of effective write cycles of flash storage, which is a big concern and an area of focus for flash vendors in general. And it can, of course, reduce the effective cost per gigabyte to the end user. So from that, what we see as requirements for deploying dedupe or data optimization of any kind within a flash storage architecture is that you need to meet or exceed the performance and latency requirements of the use case. Again, these storage systems are being purchased specifically for use cases that have very demanding performance requirements in terms of IOPS, in terms of latency. And the number one thing you can't do is compromise that. And that's the number one challenge that we've seen with third-party deployment of deduplication technologies, is that, as I mentioned at the beginning, it's very hard to develop, so there's efforts to use existing open source projects which may work for a couple dozen gigabytes or a couple hundred gigabytes but don't scale to the use cases in the real world. There are efforts to build something quick. We can build something quick and we can replace it later. And that works at first, but again, you run very rapidly into these capacity limitations, into these scaling limitations, where you can't then deliver that functionality in a way that maintains performance. So it's necessary to maintain the existing performance of the storage system, but you also have to do that at the scale that the application demands. So that's not a 100 gigabyte application where Flash was originally deployed for very small scale systems. Now, as we heard from vendors earlier, that there are multi-tens of terabytes, multi-hundred terabyte Flash storage deployments for application use cases. And if you're deploying a 100 terabyte or a 200 terabyte Flash storage system, you need your deduplication to work across that entire 100 or 200 terabyte Flash storage system. It can't just work on a 100 gigabyte data set at a time. Additionally, you have to be able to deliver this in a way that doesn't greatly increase the cost of your storage system, that this is something that you're already integrating this feature to save money for the customer. So if then you say, well, we'll save you money if you have data that deduplicates, but you have to put in an extra $100,000 worth of DRAM in the box to make it run, then that's going to be something that both the vendor and the customer aren't going to be interested in. So as I mentioned, everyone's tried to build this themselves, or a large number of vendors have tried to build this themselves. And so this is either through adapting or trying to integrate existing open source projects, which are largely experimental projects around deduplication, or to build something from scratch while also trying to build 7 other layers of the storage system at the same time. So there's kind of an old joke when you're selecting across a variety of attributes on a technology that you can pick, say, 2 out of 3. What we've seen in the market is largely it's pick 1, if that. You have a choice between the ability to scale to a large capacity of storage, you have the ability to deliver very high performance for that deduplication, or you have the ability to be very efficient in terms of the resources that are being used. the shipping products that are out there. So all these are blind references to vendor products, but everyone talks about what their product is going to do when it ships. The numbers here are from analyst data on actual systems that have been tested, so that are in GA or have at least thorough customer deployments at this point. And what we see universally is that they're all quite small in capacity. So these are all flash-based storage systems. That the largest ones scale to around 20 terabytes of usable, of protected storage. So this isn't the amount of flash. This is after data protection. This is after RAID or equivalent has been applied to the storage. But the capacity that they're able to address with deduplication is extremely, extremely low. At the same time, the I/O performance is very variable across the storage systems. So we see one vendor that is able to, for example, address a mixed workload at about 200,000 IOPS, which is very good for flash storage systems. But the overhead that requires is on the order of 6 gigabytes of DRAM per terabyte of storage in the box. So that's one of the things that limits the capacities of these systems, is that for any reasonable sized storage system, these in-house deduplication technologies require hundreds of gigabytes to half a terabyte or more of DRAM in order to deliver that functionality, and that adds enormous cost, because one, it's limited in what sort of platforms are available that can even support that amount of memory. That these are ones that are often used for very costly use cases like in-memory databases. And second, the DRAM itself, of course, is very expensive and adds cost overhead directly with the promise of reducing cost. And that, of course, is not guaranteed when you're initially spending the money on the DRAM. So a product that I talked about in April, which is a GA product that we offer now to OEM integration partners, is what we call a VDO, or Virtual Data Optimizer. And the current GA release of that product, so this is a full thin provisioning deduplication storage layer for Linux. The current GA release is able to address 256 terabytes of protected storage, that we're able to deliver a blended workload in excess of 250,000 IOPS. And we're able to do that with about 125 megabytes of memory per terabyte of storage. So this is a technology that we've been able to integrate with our partners into extremely large storage systems, extremely large flash storage systems, all the way down to very small embedded storage systems. So going back to what I said in April and at the beginning about flash displacing kind of 15K RPM SAS storage. So we have analyst data that actually supports that. The grayed area to the right, of course, are projections on what they're saying, and they're showing kind of linear adoption of SSD. So here, these are the charts here refers to specifically enterprise hard drives. So those are 10 and 15K RPM disks, and those are storage systems incorporating 10 and 15K RPM disks. And the blue line is enterprise flash, so flash-based storage systems in units shipped. And you can see that that flash has in fact been displacing those very costly high performance for hard drives, high performance drives. But again, the analyst projections are that it's only going to continue a kind of linear displacement of those very costly hard drive-based systems. So the question that, of course, we have is what's holding flash back from much more aggressive growth against hard drive-based systems, 15K SAS-based systems, which really don't make any sense to deploy. Now, why would you deploy this extremely costly system that barely meets your performance requirements when you can get something a lot cheaper? And what we see is holding that back is first delivering the technologies in the first place. So these are all vendors that are largely trying to develop deduplication at the same time as they're developing flash management. So they're developing their own flash translation layers for management of the underlying storage, for wear management, and so forth. They're trying to deliver architectures for performance, and those are both scale-up architectures and scale-out architectures. That we've previously built clustered storage architectures at Permabit around an enterprise storage array, And there are a lot of challenges there, let alone trying to address everything else at the same time. So there's wear leveling and latency management within the flash translation layer. There are interfaces, NFS interfaces, CIFS interfaces, iSCSI interfaces, fiber channel management, InfiniBand management. All of these things have to be addressed in these storage products. And at the same time, they're either using an existing file system, or they're working then on building their own file system, or building their own block-thin provisioning layer. So there are a whole bunch of different technology areas that these companies are trying to develop at the same time. And each of these is a multi-year project. So what that means, and this was mentioned earlier as well, is that many of these new storage systems that deliver very high performance and maybe even cost-effective performance are missing basic enterprise functionality. And so they're not able to compete with the incumbents. If you look at a high-end flash array, what's that displacing? It might be displacing EMC symmetrics that's being used for database, for high-performance databases that's loaded with shelf after shelf of 15K RPM drives that only a small percentage of those drives are actually being used. Incredibly costly storage system, but it comes with a long history of functionality, a long history of kind of expected enterprise functionality that customers depend on. Sometimes customers depend on it, sometimes those are checkboxes, but there's a whole host of capabilities that these incumbent storage systems from the big vendors provide that's simply not available from high-end flash arrays or even mid-range flash arrays, that there's a functionality gap there, that they can deliver performance, they can potentially deliver cost effectiveness, but they're basically flash JBODs. So features that are missing in a lot of these systems are things like basic high availability functionality. So basic enterprise functionality is high availability, and some of these systems don't have that today. That means that they can't displace these legacy systems, that they don't have snapshotting beyond, for example, what Linux's LVM can provide, which is a very, very limited view of snapshotting, a very, very limited view of clones. That replication is accomplished using existing tools like rsync. And rsync is a great tool, but if you're building a high-performance enterprise storage array, you're going to have to move beyond that, especially if you're in an environment where for example, synchronous replication is required. And the other thing that these are all missing, of course, is management and enterprise software integration. That this is another box that comes into your environment that doesn't have a lot of integration with your existing tools, be it vSphere or otherwise. And so incumbent vendors can continue to sell very costly storage arrays because of these ancillary features, which essentially have nothing to do with the underlying storage. So the product that I introduced in April and that I mentioned we've now achieved new performance targets and capacity targets with in the current GA release is a product that we call VDO, or Virtual Data Optimizer. So the Albireo product family, which I spoke about in April, is Permabit's family of OEM licensed technology for deduplication and data optimization. So the first product that we introduced 3 years ago is our Albireo SDK, which is a software library which integrates into existing software or storage products to deliver deduplication functionality. It's built on technologies we've been developing since January of 2000. So we have a whole background in our understanding of how duplicate data appears in real-world data sets. We have a whole host of IP that covers how we're able to achieve deduplication with extraordinarily low memory footprints and very high performance. And we've taken that technology and we've packaged it up to enable existing storage vendors to focus on their key areas of expertise. If you're a flash storage vendor and you're focusing on how can I make my flash more reliable, how can I make my flash have more predictable latencies, how can I increase the longevity of my flash storage system so that that's not a concern for my customers, that you shouldn't have to solve deduplication problems as well. And so we provide a toolkit that allows our partners to integrate deduplication into their storage systems without compromising performance, without compromising functionality, and with allowing them to integrate in ways that allow them to differentiate against other licensees. But the other product that we introduced last year is VDO. So a huge number of these flash storage vendors are building products around standard Linux architecture. As I mentioned, there's a whole bunch of things you have to solve when building a storage system. And you should be able to focus on your area of expertise You don't want to have to build your own storage stack, and so that's what Linux provides for you. There's a free toolkit that gives you your own NFS server implementation, that you can use Samba for CIFS, that you can use LVM for volume management, that you can use LVM for snapshotting, and so on and so forth. And some of those areas, the existing technologies are good enough. But in some of those areas, they aren't. As I mentioned, for example, LVM is very limited in what capabilities it has. Or there's no robust thin provisioning solution for Linux today. And so that's what VDO is. VDO brings data deduplication and thin provisioning to a standard Linux platform. Plugs into the device mapper level, which is a standard kind of block abstraction within a Linux device, and adds very robust, scalable thin provisioning, and thin provisioning that can operate at down to a 4K granularity as a prerequisite for enabling deduplication. We have a release of VDO that's optimized for these flash-based storage systems that we're able to deliver more than 1 gigabyte per second of performance, and that's actually using just a single core of a modern Xeon processor. We don't interfere with the reliability of the storage system, so when you get a write committed, in fact is committed, there's no game playing with caching data and compromising the reliability or high availability of the array. And it allows our partners to leverage the existing features that they've already adopted or implemented, so existing file systems. Anything above us, they can continue to use. Anything that's below us, they can continue to use. It doesn't interfere with their flash architecture at all. So it's really a drop-in solution for Linux-based storage systems with the opportunity to differentiate further. So that's one set of functionality, but the other pieces of functionality we've really identified are what's holding back some of these systems from moving more aggressively against existing incumbent enterprise vendors. So while VDO today in GA provides thin provisioning and deduplication for releases in 2013, we've identified a number of areas where we want to deliver best-of-class functionality so that our partners can focus on what they do best. So that includes features like traditional compression. Compression gives you generally less savings than deduplication, except, as we talked about earlier, Flash is being used for virtual server and VDI, where deduplication is really the best solution. Flash is also being used for database applications where you need compression, but again, you need compression that doesn't compromise the performance of the system. And that can be a challenge because compression inherently must be in your read path, so it inherently must introduce additional latency on read, which is an enormous concern. Will be delivering very robust snapshot and clone functionality. So that these Linux-based Flash products will be able to compete head-to-head with existing enterprise storage products. We'll be providing deduplicated replication that leverages the same deduplication engine that we have for deduplicating locally to make sure that redundant data is never sent over the network. And then working with our partners, we'll be delivering features including local caching, so hybrid storage systems. So VDO is available for both disk and flash, and we'll be able to make use of the flash in hybrid storage systems for local caching, as well as local caching of cloud-based storage. The final area that I'll mention is, as I mentioned, integration with existing management software, existing enterprise storage is a barrier to entry against disk-based enterprise storage systems. So we'll be delivering integration with a number of different platforms for both management and backup integration with existing products. So really to wrap things up, we see that deduplication is an absolute requirement to compete effectively in the flash space. Every vendor you heard from this morning says they have deduplication, sees that as critical to compete. Some of them can only dedupe to a very small capacity. Some of them can only dedupe at a very slow data rate. Some of them require a huge amount of additional hardware to implement that deduplication, but all of them have recognized this is something they need, and they need to either build it themselves or they need to use a licensed technology such as ours. That by integrating deduplication, you deliver a fundamentally better product to your customer because it enables additional use cases. It doesn't harm the performance that they're purchasing the product for in the first place, and it reduces their overall cost, which really means that they can buy more storage for more use cases. So what I see happening in 2013 is that flash storage growth will continue to displace this 15K and 10K RPM hard drives, that data optimization is going to be an even stronger requirement than it is today. And by introducing more complete enterprise feature sets, I think that we can substantially change that curve I showed before from linear displacement of SAS drives with flash-based storage systems to something much more aggressive. And perhaps I'll be back next April to see how accurate that prediction is. And hybrid systems I didn't talk a lot about, but they really have the same requirements. Whether or not you think a hybrid model is a successful model for a storage architecture, the requirements are the same in terms of maintaining performance, in terms of delivering cost effectiveness through data optimization technologies. And so as you see hybrid storage systems develop, they have to deliver the same levels of performance, the same levels of cost savings, and the same levels of enterprise functionality if they hope to displace the incumbent vendors. Thank you.